Hi guys, welcome back to the channel. Today we are going to master functions. Now I know that word might sound scary if you are a complete beginner, but trust me, by the end of this video, function will feel like your best friend. They are the most powerful tool a programmer has, and once you understand them deeply, your code will become cleaner, smarter, and much more easier to read. So let's not waste any time. We have a lot to cover today, and I want to make sure every single one of you understand every topic step by step from zero. So in this video, we will cover almost every topics about functions, like basic function syntax, like how to write and call a function. Okay. Then we will talk about function with multiple parameters, passing more than one values, something like that. Then we talk about polymorphism in functions, functions that work on different data types. Okay. Also, we will learning function returning multiple values, like getting more than one result back. Also, default parameter values like making argument optionals. Also, we will talk about lambda functions, like writing tiny anonymous function in one line. We will also talk about accepting any number of positional argument, and also we will talk about accepting any number of keyword arguments. Okay, and also we will learn a generator functions which yield a powerful memory saving technique, something like that. And also in the last we will talk about recursive function, a function that call themselves. Okay, we will also look at some bonus concept like function as object, and function that return other objects, and mutable default arguments. So stay with me until the end of this video. A single line of code, I want to make sure we all truly understand what a function actually is. And for that, let me give you a real life example. Okay, let's say think about a chai tea recipe. Every morning, your mother or grandmother, something like follow the same steps to make chai. She boils water, added tea leaves, added sugars to it, added milks, and serves it to you. She does not invent a new method every single day. She knows the recipe, she follows it. The recipe is like a function. Okay, in programming, a function is a block of code that you write once, give a name to it, then you call it, run it as many times as you want from anywhere in your program. This is called code reuse, and it is one of the most important principle in software development. Okay, so now the official definition could be like a function is a named sequence of statement that perform a computation. Okay, when you define a function, you specify the name and the sequence of a statement. Okay, later you can call the function by name. So function has three parameter, and one is a name, so you can call it later, and another one is parameter optional, which is input, optional input it can receive. Okay, uh, and third one is a body, the actual code that runs when the function is called. Okay, the question you may be thinking, why use functions? Let me give you five powerful reasons why we use function in programming. One is reusability. Write the code once, use it many times, no more copy pasting the same logic. Okay. Another one is readability. A program made of well named function reads almost like plain English. It is much easier to understand. Okay. Another one is debugging. When something goes wrong, you only need to fix the function in one place, and it is fixed everywhere. Also, another one is abstraction. You can use a function without knowing how it works inside, just like you use your phone camera without understanding the electronics. Okay. Another, and the last one is organization. Like function let you break a large complex problem into smaller manageable pieces, something like that. Syntax. Okay. So, in order to define a function in Python, we use the def keyword. This is stand for define. Let me show you in structure like def. Okay, this is a Python is a keyword to define a function. Okay, after that we give a function name. We give the whatever the function name you want to give. Okay, after that we give parentheses. Inside the parentheses we write parameters. Okay, after that we hit colon, then after that you see that four indented spaces. Okay, here you can write your code. Okay, body of function. This is the Let me just pass it. If I did not pass it, when I run it, it will give me an error. Let me show it to you. Okay, you see that indentation error. Okay, so I have to write here pass in order to avoid the error. Let me just run it again. Now you see there will be no error shown here. Now notice few things that this keyword tells Python I am about to define a function. This def keyword. Okay. After that we give this function name. Okay. This is name we give it. Use lowercase letters and underscores like snake case. After that parenthesis you see hold the parameters. If there are none, we still write empty parenthesis. Okay. After that you see the colon. The colon at the end is mandatory. It tells Python the function what is about to begin. Okay. After that you see the indentation. Okay. Everything inside the function must be indented by exactly 4 spaces. Okay. This is how Python knows what belongs to the what function, something like that. Okay. Write a function to calculate and return the value of square of a number. Okay. What we will do, we will uh, square a number. We will square a number. Okay. First, what does square mean? The square of a number is that a number multiplied by itself. So the square of 7 is 7 into 7 is 49. The square of 4 is 4 into 4 is equal to 16. Here is our first approach using print function inside the function. Okay. So we will define. We need a function. In order to define a function, we use the def keyword. After that, we use function name. Let's give it like a square number. Okay. After that, we will write parentheses. Inside the parentheses, we write our parameter like let's say x. After that, colon. We hit enter. We will say quote unquote print x double asterisk then square. This symbol is uh, power symbol. Let me just break this down. Okay. Def square like this line. Okay. We define a function called square number. It takes only one input called x. Okay. Now this line inside the function we write print x raised to the power of 2. In Python, double this asterisk symbol means to the power of. Okay. Okay. If there is only one asterisk, that means we are multiplying that we are multiplying this whatever the x value is by 2. If there are double asterisk symbols, then we are in Python that means power of. Okay. So let me just now when I run it, you see there is no output because here I just define a function. I did not call here. So I need to call here. Okay. If I am using print statement inside here. Okay. So I will say quote unquote whatever the function name is, which is square number. Okay. After that, inside the brackets parenthesis, you see there was a parameter which is x. Now I have to define the value of what is the value of x. So let me just say I need to know what is the square of 5. Okay. So when I run it, you see that here will be shown 25. Okay. You know that square of 5 is 25. What is the difference between using print statement in the function or using return statement inside a function? Okay. So let's see what happens if we try to store the result of our function. Let's just say if we try to store our result. First, let me break it down like that. This write some comments like that. What does this line do? This line just print only prints. Okay. It returns nothing. Okay. This line here we are calling the function. Okay. So what happen if we try to store this result? We know that when we run it, the value is just 25. Okay. What if we try to store this result in a variable? Let's just say in a variable called result, we store that value, and after that we print whatever that value is. Okay. Now what do we get? Let's just say here, what do we get here? We get quote unquote none. Uh, did you notice that we got 25 printed from the inside the function, but when we try to print the result, we get none. Why? Because print inside the function, because you see that a print inside a function just displays a value on the screen. Okay, it does not give anything back to the caller. In Python, a function that does not explicitly return a value automatically returns none. Okay, none is a special Python object that means nothing or no value. Okay. Okay, so you see, let me just uncomment this line. So I what if I say I don't want to run this line? When I run it, you see only 25 is printed because we are calling the function here. Okay, this is inside the result variable. But if we try to print uh, the result value, you see that we got the none as an output. This is one of the most beginner mistakes. Always ask yourself, okay, do I want to display a value or do I want to use a value? Something like that, okay. Return statement, okay. So to give a value back to the caller, we use the return keyword. So let's just rewrite the whole function like a def square number, okay. After that parameter, then we will write here that quote unquote return keyword, okay. After that we will say x double asterisk 2, okay. After that we will say that we will call the function which is a square number. In that we will say, let's just say 10. Now we will put this in a result variable, okay. After that let me just show to you here. When I'm not printing anything on the screen, okay. So you see that this 25 comes from this line, okay. This none variable comes from this line, okay. Let me just give a line here, blank line, okay. This line comes from here. After that, this now here the value is 100, so I need to print it out. So I will say print whatever the result is, so it will print it 100 here. So now let's understand what happened step by step. So Python first sees here square number 10. So jumps into the function with x is equals to 10. Okay. Inside it, it calculates 10 into 10 power of 2. Okay, which gives back 100. So the return statement. So now this return statement, okay, sends the value 100 back to wherever the function was called. So function was called here, okay. So we store that value in a variable called result, okay. So now here result is 100, okay. So after that we print whatever the value is, okay. You can also skip the variable and print directly, like print quote unquote what is the function name, which is square number. Let's just say if you want to find out a 7 square number, you will quote unquote, you see this 49 here. This way also works, this way also works if you are using the return statement, okay. Here here Python first call the function, okay. Here Python first call the function and gets the value 100, okay. How did he get that 100? You see from here, it calls here and it gets the 100 value here, and pass it to the print function, okay. This into the print function 100, and that will print it out, sorry, 100 not 100, 49. This 49 is here, okay. This is called function composition. It is very common in Python, okay. So let me just give you a rule here, what we are learned right now, okay. So if you are using the print function here, if you are using print function inside the function, then do not use outside print, okay. like that, you will get an none, okay, here output as an output. Just use, if you are using a return statement inside the function, so you can use the uh, print outside the function. Okay, if you do not use this print value outside the uh, function, then you will not get the result whatever that is. Okay, function with function with multiple parameter. Okay, function can accept more than one input at a time. These input are called parameter. When we define the function and arguments, what we actually call the function, and pass real value. Let's solve the next problem. Okay, the problem is like create a function that takes two number as a parameter and returns their sum. But first, let me just try to give you the concept of what are the parameters and arguments. What are the this? This is the concept that many books use interchangeably. But let's be precise here. So the parameter is like the variable name inside the function definition. Okay, it is like a placeholder or slot where this right here, this x is a parameter. Okay, this x inside the function definition. Okay, this is a parameter. So what is the argument? The actual value you pass when you call the function. It fills the slot like here. This is argument. Okay, this is argument like this here when we calling the function. Okay, so think of it like a form. The form has a blank field, so it is parameter. When you fill in the form, you write actual data. So let's just write a function. We will write a function. What it will do? It will takes two parameter, okay, and return their sum. Let's just give a function name like sum of two number, okay, numbers. This is the function name, whatever you want to. After that you see the parenthesis. So this is the parenthesis. Inside the parenthesis we need two parameters, like one, let's just say x. After that comma, we need another parameter, let's just say y. X is one number and y is another number. After that we need colon. After that we hit enter, and we will write quote unquote return x, uh, whatever the x value is added to the y value. Okay, now we need, let's just say, we will say sum of two number. We were calling the function, and inside the parenthesis, now we give two values here. Okay, one value is for the x parameter, okay, here x argument, and another one is for y parameter, here y argument. Okay, so we need, let's just say, 3 comma 2. Now 3 is belongs to the y parameter and 2 belongs to the 3 belongs to the x parameter and 2 belongs to the y parameter. So here 3 is a 3 argument, and another argument is 2. Okay, now I need this in a variable. Okay, so I can say that quote unquote result, and I, whatever the this value is, okay, it will give me a 5 as a value. So now I am adding this in a result variable. Okay, after that I am printing quote unquote whatever the result is. Now you will see 5 as an input output. Okay, so you see, so it will take here 3, this 3, and y as this here, then it will add it and back gives us back to the 5 value. We store that 5 value in a result variable. Okay, after that we print it. You can do it in the print function like sum of two number. Okay, after that after that inside the brackets you will write the x argument, x parameter value, which is, let's just say, 10, and a comma. After that you need another value like for the y, so let's just say 10. When you run it, you will see 20 here. When we call object to object, Python assign x is equals to 2 and y is equals to 3 in order. These are called positional argument. In the order you write them matters. The first argument goes to the first parameter, and the second order the second go to the second, and so on, something like that. Okay, what happens, what if you pass wrong number of argument? Okay, here only one argument, okay, just three. So it will give me a type error which says missing one required positional argument, okay, which is y. Okay, you will get an error. What if we write too many arguments? Let's just say 3 is for the x, 2 is for the y, and we write another argument, let's just say 4 for, we did not define the parameter for that 4 argument, but we are just giving it in the result variable. When we try to print it, it will also give us a type error which says two positional argument, okay, two positional argument, here two positional argument, but three were given, but here three were given. We only define two arguments, two parameter, but we give three arguments. That's why we are getting this type error, where in line 34, as you can see, it will also try to give you in which line. So Python will raise a type error in both cases, telling you exactly how many arguments were expected versus how many were given. Okay. Later we will learn how to make this more flexible with asterisk args and default values. Okay. So let me just rewrite this in a normal way. Okay. Now we are good to go. Perfect. Morphism. Morphism in function. Let me just give a line here. Blank line. Okay. Okay, the word polymorphism comes from Greek word like poly means many, and morphe means forms. So polymorphism means many forms. In Python, this means a single function can behave differently depending on the type of data you give it. Okay, so Python is what we call dynamically typed language. So you do not need to declare what type of variable x is. Python figure it out at a runtime. Okay, this makes polymorphism very natural in Python. Let me just give you an example. Let's just say def. We write a function name which is multiply. Okay, it only takes two arguments, like one is x, another one is y. Okay, we will return whatever the value is. Let's just say x multiply by y. Okay, so now here uh, first form is like print quote unquote what is the function name, which is multiply. We will write we want to multiply 3, let's just say, into 9. Okay, when you run it, you will see the 27 as answer. So now what happen if we just say quote unquote multiply, and here we will, now we are giving the first argument as a 3, okay, comma another argument. We are writing this in a in a string, so we know that that is a string data. Okay, like let's just say 3. So when we run it, you will see that 3 three will print it out 3 times. You see that 3, this here 3, because this x is multiplying into y. Okay, we can change this, like we can give print quote unquote multiply. We can do this we can give 3 as first, after that we can give. Now when we run it, you see that output will be same, but you can switch the uh, values here. You are asking yourself that the same function, the same operator, but completely different behavior. Why is that? Let's understand why. In this line, both x and y integer. Okay, so this symbol performs arithmetic multiplication, like 3 multiplied by 9, which is 27. That's why 27 printed here in this line. Okay, when one is string, you know that and one is an integer. You know that one argument is an integer and another argument is string. So Python operator, this operator, multiply operator, repeats the string that many times. So 3 three repeats 3 times. Okay. Also you notice that multiply these two lines uh, gives the same result because multiplication of string is commutative in Python. This is polymorphism at work. This function multiply adapts to the types of it receives without needing any if statement inside it. Python operators are already polymorphism. Function returning multiple values. Okay, what happen if a function returns multiples values? So in many languages like Java or C++, a function can only return one value. Okay, but Python is much more flexible. You can return multiple values from a single function. Okay, this is extremely useful in this practice. Let's just create a function that returns both the area and the circumference of a given circle. Okay, given its radius. First, let's quickly refresh the formula. So we know that the area of a circle is pi multiplied by r square. Okay, and r is a radius. Okay, and the circumference of a circle is like 2 multiplied by pi into r. Okay, in Python we have the math module which give us a very precise value of pi. Let's use it the math module. Okay, so first we will say import quote unquote what is the module which is math. After that we will say def define as we will say circle. It takes one argument, one parameter which is radius. Okay, after that we need to circle area. Okay, inside it we will say math dot pi. Okay, and we will say asterisk radius. Okay, whatever the radius is given, and we will power it 2. Okay. Then we will say circle, then we will say circle circumference is equals to like 2 into math dot pi. It will give us pi value. Okay, and multiplied it by also with whatever the radius is. Okay, after we will say return quote unquote whatever the circle value is. Okay, comma quote unquote what is the circle circumference value is. Now we get the return value. That after that we will say area comma circumference is equals to circle. We are calling the function and we are giving the radius, let's just say 4. Okay, then we will print whatever the value is. Let's just say area is whatever the area is. Okay, after that print f string. Okay, whatever the circum circumference is. Okay, whatever this. Now when we run it, you see, let me just give a blank line here. So when the radius is just 4. Okay, so what is the area? Area will be 50 dot something. Okay, and the circumference will be 25 point something. Okay, so how does that work? When you write object Python does something clever. It bundles both values into a tuple. Okay, a tuple is a collection of values wrapped in the parentheses separated by commas. Okay, Python does this automatically even without the parentheses. Okay, Then on the receiving side, when we write object, Python automatically unpacks the tuple. Okay, it assign the first value to the area and second to the circumference. This technique is called tuple unpacking or destructing. Okay, you must have exactly the same number of variable on the left side as there are written values. Okay, if there are function returning two values, you need two variable to unpack them. Okay, you can also capture everything in one variable, like result is equals to circle 4. Okay, and just print whatever the result is. So first one is area. Okay, another one is circumference. Here circle area, this, and circle circumference. About default parameter values. Sometimes you want a function to work even if the caller does not provide every argument. For this, Python lets you use set default values for parameter. If the caller provides a value, that value is used. If not, the default value kicks in. Okay, we will write a function that greet a user. If no name is provided, it should greet with a default name. Okay, so so we will say def greeting. Greeting is just a function name. Okay, inside it just now here we will write our default value. We will say name is equals to which is user. Okay, after that we will say uh, return what to return. We will say f string, and inside the f string we will say hello whatever the name is. Okay, we will provide the name. If not, okay, after that we will say hope you are doing well. Okay, after that we will just write print uh, greetings, quote unquote, whatever the function name is, which is greetings. Inside this we will write, let's just say what is the user name. We will just say, let me just write my name. Okay, so when I run it, it will just say hello. Whatever the name was here, it will print out whatever the I give name output. So hello guys, hope you are doing well. That's something like that. If we use print, now I am giving default argument. Okay, so it will say hello user instead of Wahid. Okay, so when we pass Wahid as a value, that value is used for name. Okay, when we call greetings with no argument, Python uses the default value, which is user. Whatever you defined here will be default value. Let me just say just a random word, so that whatever you define in the name argument parameter, it will shown here. Okay, so important rule you need to know. There is one critical rule. A parameter with default value must always comes after parameters without default values. Okay, this is because Python assigns argument by position. Okay, if a required parameter came after an optional one, Python would not know which function we have written use the def keyword. Okay, and has a name, but Python also allows you to write a small quick function without a name. These are called lambda function or anonymous function. Lambda comes from mathematics, specifically from something called lambda calculus, which is the theoretical foundation of functional programming. You do not need to know the math, just know that in Python lambda means a small uh, throwaway function. Okay, the syntax is like we will write lambda as a quote unquote keyword, which is Python reserved keyword for lambda function. Okay, after that we will arguments. Okay, whatever the argument is, then colon, then we will write our expression. Okay, let me just comment it out. Okay, this is the syntax for the lambda function. First comes the lambda keyword. Okay, after that whatever the arguments are, okay, then the whole expression. Key points about lambda function, that anonymous, they have no names unless you assign them to a variable, okay. Single expression, like they can only contain one expression, not multiple statement, okay. Returns automatically, no need for return keyword, okay. The expression is evaluated and returned, okay. Also the closure, they can access variable from surrounding scope. So let's create a lambda function to compute the cube of a number, okay. So first we define a cube variable. Inside the cube variable, we will write lambda keyword, quote unquote, for example Python keyword is a part, okay. After that we will say our argument is x, okay, comma, colon, then we will write our expression. Let me just say we want cube, so we will say x. So now we will print cube, okay. After that, what is the argument, what is the value of x, okay. Here this argument x, what is the value, we will define, we will say, just let me just find out 4 cube, it will say 64, okay. Here we assign the lambda function to a variable called cube. Now cube behaves exactly like a named function, okay. When we call cube 4, it computes to 4 power of 3, okay, is equals to 64. So when we use lambda functions, lambda function are most useful when you need a small function for a short time, specifically when passing a function as an argument to another function, okay, something like that. Also, lambda function are also common in web frameworks like Django or Flask, and in data libraries like pandas. Whenever you need a small inline function, lambda is the tool. Function with asterisk args, for short form means args means arguments, okay. Short form is args. What if you do not know how many arguments someone will pass to your function? For example, what if you want a function that sums n number of numbers, like 2 or 5 or 100 or something like that? For this, Python provide a specific syntax style like the asterisk symbol, okay, before the parameter name. By convention, this parameter is named args, short for argument, but you can technically name it anything, okay. So what does asterisk args do? When you use asterisk before a parameter, Python collects all extra positional argument into a tuple. Okay, a tuple is like a list, but it cannot be changed. It is mutable. It is immutable. Okay, inside the function, you can loop through it, pass it to the other function, or do whatever you need. Okay, we will write a function that takes a variable which is number of argument and return their sum. So we will write a def keyword for a function, and we will say sum all. This is function name, okay. After that we will inside the brackets we will write asterisk symbol, okay. After that we will say args, whatever you named it, it will fine, but go to the Python convention which is args, okay. After that colon, then hit enter, we will say return whatever the args, or do the sum, okay. Sum is another function which added the values, okay. So args. So now here will I will ask, here I will, so here I will print quote unquote will whatever the function is, okay. If I did not give anything here, okay, so the output will be 0, okay. Let me just give a line here, okay. So now let's just use different arguments like in the sum all function. Let's just say this, first we will use first argument, okay, which is just 8. It will print it out here whatever you defined here, okay. If you did not give anything here, it will be 0. If you give it whatever you give it, if one argument given, that will be here, okay. If 2 is given, if 2 argument is given, let me just write here, okay. Let's just say 8 quote unquote comma, then 10. Now it what will without it will be 18. Why? Because this sums will added whatever the arguments are, which is 8 and 10. It will added them both, okay. You can give as many as you want, okay. It's up to you. let's just say 9 comma 3 comma 1 comma 10. Okay, now I have given 4 argument. Okay, after that answer the answer will be 23. So we are using the sum. So we are using some function which is a Python built-in function which is added up all the values in sequence. Since asterisk args gives us a tuple, sum works perfectly on it. Okay. Also you see that inside here I did not define how many parameters are or arguments are here. I did not say here x is a first variable, first argument, y is another variable, okay, z is another. I did not define that. I just define a symbol which is asterisk. After that, I give a name which is args. Okay, and this works fine with function with asterisk args. Okay, let so what is inside args? Let me just print directly so you can see what it really is. So we will say here print quote unquote what is args. So when we run it, you see inside the tuple there is nothing. That's why it is printed 0. Inside the tuple and there is a 8, so that's why it is printed. Inside the tuple there are two arguments, which is one is 8, another is 8 10, so that's why it is printed out. Where does that come from? You see that this is here line, it first printed out this line, then returns whatever their sum is. Okay, so you see that this line, whatever we type here, it prints whatever we type args value, we type that 9 3 1 10. Okay, and that printed out here. Okay, so also we can iterate over arguments because args is a tuple, so you can loop through it with a for loop. Okay, so let me just create a test. Let's just say sum all. First create a little print statement here. Okay, def sum all, and we will say we do not know how many arguments we will given. That's so we are not defining here a b c d something like that. We are just giving it asterisk symbol. After that args. So no need to worry about arguments. Okay, after that we will say for I. Now I am looping on it, whatever the args is, whatever the arguments are. So that's why I am saying for I in args. Okay, after that I will hit enter, and then I will say print quote unquote whatever the I is when I loop on it, then multiply it by 2. Okay, so double this will do what will do, it will double doubles each argument. Okay, after that I will say return quote unquote whatever their sum is. Let me just print something. So I will say sum all. Inside it let me just give 1 comma 2 comma 3. When I run it, you see that each time when we looping on it, first goes the 1 here. Okay, now I becomes 1. So after that in the args, in the argument I becomes 1. So I 1 is multiplied by 2, which is 2. So it whatever. Okay, so 2 here is printed out. After that I becomes 2. Okay, in the arguments. Okay, so 2 into 2 is 4. That's why this 4 is here. After that 3, this 3 becomes I in the arguments. So it will multiply by 2. So 3 into 2, which is 6. Okay, after that uh, we said return whatever their sum is of argument. So it will sum these three plus 2, which is 5, 5 plus 1, which is overall 6. That's where this last 6 comes from. Okay, so now notice that at the end is the return value from the sum args. The 2 4 6 are from the loop printing each item doubled. Okay, then using asterisk arg alongside regular parameter. Okay, so regular parameter must comes first. For example, like this def. After that we function name. Okay, after that inside this parenthesis parameter must be like These are our regular parameters. Okay. After that, we will say asterisk args. Okay. The x and y captures the first two argument, and the asterisk args gets everything else. Okay. Talk about function with double asterisk key w args. Just like asterisk args lets you accept any number of positional argument, Python provide double asterisk key regs to accept any number of keyword argument. Okay, the double asterisk collects all keyword arguments into a dictionary. The name key wargs or regs stands for keywords argument. Okay, so but again you can name it anything, but it is just a convention. Okay, Python convention. You know it. You know it. So also, what is a dictionary? A dictionary is a collection of key value pairs. Like a real world dictionary has words like keys and has definition like values. Okay, a Python dictionary store data as name. Okay, like value pairs. Okay, when you use double asterisk key regs, keyword arguments. Okay, every argument name becomes a key and its value becomes a dictionary value. So now we create a function that accepts any number of keyword argument and print them in the format key value. Okay. Okay. So that's company info. This is our function. Inside it, we will write double asterisk. Okay. Then after that key args. Okay. Key args or keyword arguments. Okay. After that, we will say we will now looping on it. Okay, we will say for a key comma value in uh, key args. Okay, after that dot items because it's a dictionary, that's why. Then we hit enter. Okay, we will separate quote unquote. Okay, f for string format. We will say whatever the key is, just print it out, and comma whatever the value is. Okay, we will just say company info. We will calling the function name. Inside it we will say name. So inside it we will say name is equals to, let's just say Tesla. Okay, company is Tesla. After that we will just say, let me just say CEO is our Elon. Okay, and also let me just say founded. When it is our founder, let me just say uh, 2000. Okay, 2000. So when we print it, so here three, uh, here one, this one is a keyword argument, another one is this one, and third one is this one. Okay, so this is a key name and value is Tesla. This is key Tesla. This is key CEO, and this is Elon. Its value. This is key and this is a value. Okay, in, so when we run it, you see that. So when we run it, you see that name and CEO and all three are printed because we loop on everything. We loop on first on key, then value. Okay, in keywords argument whatever we type here. Okay, so also we can give uh, company info. Also we can give as many keywords we can give. Let me just say name is equals to uh, Abdul Wahid. Okay, when I run it, you see this right here. Okay, I can also say company info. Okay, x is equals to 1.1 comma y is equals to 2.2. Okay, so now when I run it, you see this is the output we are getting from this line. this colon is coming from here. Okay, whatever the key is, it is on the left hand side, which is x. Here key is x, here key is name, here key is name, here key is coc founded. Okay, these are the keys, and other ones are values. On the right hand side there are values. So how does this dot items works? Okay, so dictionaries have a method called dot items, which returns all the key value pairs as a sequence of tuples. Okay, when you write like for key comma value in keyx dot items, you are asking Python to loop through each pair, and for each pair unpack the tuple into two variables. Okay, which is key and value. This is standard and most readable way to iterate over a dictionary. Okay, combining asterisk args and double asterisk key args. Okay, you can use both in the same function. The order must always be regular parameters first. Okay, and then asterisk args, then double asterisk key rags. So let me just write a function. Let's say def show every everything. Okay, after that our first we will write our regular parameters like name. After that we will give args. Okay, then double asterisk key args, then we get colon. Okay, we will say print quote unquote whatever the uh, name is, just print it out. Okay, we will also say print f quote unquote extra positional uh, args. Okay, in here we will put args. After that we will say quote unquote uh, extra keyword. Okay, here we will put key args. Let me just args keyword args. Okay, after that we will say shit. After that we will say show everything. Okay, what to show? We will first write our regular parameter, which is name. So here I will type, let's say Wahid. Okay, just my name. After that we can put as many argument as we want, because we have defined here asterisk args, so it will take as many arguments as we type them. So here I just say 1 2 3. Okay, something like that. Let's just say okay. After that I can put as many keyword arguments here. Okay, let's just say city is equals to uh, Paris. Okay, uh, age is equals to, here let me just say. So now you see that first one is name argument. Okay, a regular argument, which is our this regular argument. After that these are arguments, as many argument we want to put in here. These are the regular, also not regular arguments as many we want. These are the double asterisk means keyword arguments. You see here these are two keywords argument. Okay, when we try to run it, you see that in the name, sorry, in the name, so you see that everyone, so regular arguments comes here, and extra positional argument or okay comes here, and extra keywords arguments comes in this line. So you see these are the keyword arguments, these are the our regular arguments. Okay, and these are the, sorry, these are the positional argument, and these are the keywords argument. Or okay comes here, and extra keywords arguments comes in this line. So you see these are the keyword arguments, these are the our regular arguments, okay, and these are the these are the positional argument, and these are the keywords argument. Generator function with yield. So we are now getting into something very interesting territory, like generator functions are a slightly more advanced concept, but they are incredibly powerful, and I will explain them so clearly that even a complete beginner will understand. Imagine you have a task like print all even numbers from 1 to 1 millions. The naive approach is to create a list of all 5 lakhs even numbers and then iterate over them. But that list would take up a lot of memory, 100 of megabytes just to hold numbers. Okay? So a generator is a a generator is a smarter. Instead of computing all values upfront and storing them, it computes one value at a time on demand. It pauses after each value, waits for your ask for the next one, and only then computes it. This is called lazy evolution. Okay. So we have a yield keyword to make a generator function. We use yield instead of return. Okay, instead of return keyword. Here's the difference. Like return keyword in with the function. Okay, gives back one value. The function is done. Like versus yield statement pauses the function, gives back one value, and remember exactly where it left off. Okay, the next time you ask for a value, it resumes from the exact pause point. Okay, so we will write a generator function that yield even number up to a specific limit. So we will create a function which is even generator. Okay, in it there is a limit. Let me just limit just a parameter. We will now loop on it for I in range. Okay, so you loop on it for I in range uh, 2. Okay, so now limit plus 1 comma 2. After that, just yield whatever the I is. Now we are calling the function for num in even generator. Okay, I'm just the limit is just, let me define 10. Okay, I am quote on saying print whatever the num is. So the output would look like, okay, let me trace through exactly what happened. We call even generator. Okay, Python notice that this is a generator function because of yield and returns a generator object but does not run the code yet. Okay, the for loop uh, asks for the first value. Python enters the function I starts at 2, hits yield 2 and pauses. Okay, 2 is given for the loop. Okay, the for loop asks for the next value. Python resumes where it pauses. It becomes 4, hits yield 4 and pauses again. 4 is given. Okay, this continues. 6 comes, then 8, then comes 10. After that 10, for the for loops its range reaches limit plus 1. Okay, range reaches limit plus 1. The function returns normally and the generator is exhausted. You can also use the next function to manually pull one value at a time. Like how? Just let me just print line here. I'm just saying in the gen function we have an even generator up to, let me just say, 6. Okay. So now I am quote unquote saying print whatever the next function. Uh, in it we will pass a variable which is gen right now defined. So when I run it, you see that only 2 is comes out. When I again print and write next gen, it will give me 4 because after that is okay. Now I need 6. Let me just say print next is a function. Inside it I gave this gen variable. When I run it, you see that this comes out. What happen if I give this a next function gen? I know that limit is of is int. We see that it gives me an error which says it stop iteration. Okay, because we know that we are just calling up to 6, not greater than 6. So that's why this error comes from here. So I have to delete this line. Now when I run it, you see this is perfectly fine. Generators are heavily used in professional Python for processing large files, like streaming data, also in large files, and building efficient pipelines, something like that. They are memory efficient, you know that, because they never hold all value at once. That's the main reason. Also, you see that this range function takes three values. The first one is where to start. Okay, start at 2. Okay, after that where to end, whatever the value is, limit value, added 1 to it. That's where you need to stop. This is that means this, and how many times to increase? I mean step. So starting value. This 2 is a starting value. Okay, this is the ending value, and this is stepping value. Okay, what is the stopping value is 10 is limit. Okay, we defined here 10 limit and added 1 to, so 11 is the stopping value in this range function, that, and after that we are looping on it. So there you go. Next, now we will talk about recursive function. We have arrived at one of the most mind bending beautiful concept in all of programming, recursion. This is a topic that confuses many beginners. For once it clicks, you will never forget it. It will. I will take it slowly and use a very clear analogy. Okay. First, let me tell you what is a recursion. Recursion is when a function calls itself. Yes, a function that runs itself as a part of its own execution. This might sound circular, and it is, but when done correctly, it creates a beautiful, elegant solution to the problem that involves repeated structure. Think of it like looking up a word in a dictionary and the definition uses that same word. Normally, that would be useless, but in programming, each call has a smaller version of the problem, and eventually we hit a point where the answer is trivially known. That's what the cause. That's what the base case called. Okay, so now we have the two rule of recursion. Every recursion must follows exactly two rules like base case, and another one is recursive case. What is a base case? A base case is a condition where the function does not call itself. It runs a direct answer. Okay. Without this, the function call itself forever infinite loop and crashes with a recursive error. And what is the recursive case? This is the part where the function call itself with a simpler or smaller version of the same problem, moving step by step toward the base case. Okay, which is create a recursive function to calculate the factorial of a number. Okay, the factorial of a number n is the product of all positive integers from 1 up to n. We know that. Okay, so let me just write what will be the factorial of 5. What will be the factorial of 5, which will be 5 into 4 into 3 into 2 into 1, which will be 120. What will be the factorial of 4 factorial? It will be 4 into 3 into 2 into 1. Okay, is equals to, it will be 24, something like that. What will be the factorial of 3? It will be 3 into 2 into 1. It will be 6. It will be 6. What is the factorial of 2? It will be just 2 into 1, which is 2, and 1 factorial is just 1, and 0 factorial is also 1. So notice the pattern. You know that 5 factorial is also 5 into 4 factorial. Huh? Also 4 factorial is also the 4 into 3 factorial. Also 2 factorial is the 2 into 1 factorial. So we know that this is the recursive structure, like uh, like factorial. n is equals to into n into factorial n minus 1. You see that factorial, whatever the factorial is, which is n, whatever that n is, and we will minus 1 from that. This is the formula. So we will write now a function for this, like def, define a function. After that we need a name. Let's just say factorial, and in it we will take a parameter which is n. If n becomes quote unquote 0, just return 1. Else we will say return, but to return the formula, which is n into factorial n minus 1. Okay, so let me just find out what is the value of factorial 5. Okay, I know that it is 120, but we defined a function here. Okay, let's see what is the output, which is 120. So let me give you what is really happening. So when we call the function which is factorial 5, what it will do, it will it will comes here, ask if is n 0. No, it is not. So it will run this function which is n. Now n is 5. uh, Now what is n? N is 5. After that into, okay, into, then whatever the factorial of n minus 1. So what is the factorial of n minus 1? Now n is 5, n minus 1, which is 4. Okay, so we do not know what is the value of factorial 4. So we will do the, so we will ask, so it will ask the factorial 4. So factorial 4 would be like this will be the same. Inside the factorial 4 we will write what is the, it will comes back here, it will say is n 0. No, it is not. So it will run this else function, okay, else block, which is n into n factorial. So now n becomes 4. 4 into factorial uh, factorial n minus 1. Now n is 4, n minus 1, which is 3. Okay, so we will write 3 here. After that, do we know that what is the factorial of 3? No. So it will go again. Let me just, okay, so this is same as the, like this, then it will say 4 into, sorry, into, now it will ask what is the value of factorial 3. So it will say is n, now n is 3, is n 3? No, it is not. So it will run this block which is n into n factorial. So what is n? N is now 3. 3 into 3 3 into fact 3 into factorial 3 minus 1. Okay, so now 3 minus 1 becomes 2. So do we know that what is the factorial of 3, factorial 2? No. So it will go again and ask is n 2? No, it is not. So it will run this block. So let me just write it for you. N into, this will be same, this will be also same. Okay, 3, we know that 3 factorial also. So now here comes the factorial 2. So now n becomes the 2. Okay, 2 into, you know that 2 into what is factorial 2 minus 1. Okay, so 2 into factorial 2 minus 1. So it becomes the 1. Do you know the what is the factorial of 1? No. So it will come here and ask is n 0? No, it is not. So it is 1. So it will run this block code. So let me just write this again. 5 into 4 into 3, sorry, 3 into 2 into So now what is the factorial of 1? This function will again runs, and here now n becomes the 1. Okay, so 1 into factorial 1 minus whatever the so n is now 1 and minus it to minus it from 1. So this is confirmed. So it will becomes, you know that, 0. Now now we know that now n becomes here 0. So it will ask again, is n 0? Yes, it is 0. So now will it becomes 5 into 4 into 3 into 2 into 1 into, so 1 into, so now we know that what is the factorial of 0, this here we know that it is now n becomes 0, so it will give us back 1 value. So we will write here 1. So now this is what, now this is the what we called the base case hit. Okay, so now it will go, so now we reach the base case. Okay, so now it's easy for us to write. So now 5 into 4 into 3 into 2 into, so now so why so now we know that, 1 into 1 it will be 1. After that 5 into 4 into 3 into, so we know that 2 into 1. So now this 2 into 1 will be 2. Oh, sorry, let me just copy it. So now this 3 into 2 becomes 6. Okay, after that we know that 5 into 4 into 6 will be 24. After that it will becomes 120. So this is behind the scene how it works. Okay, think of it was a stack of plates. Each recursive call added a plate to the stack. When the base case is reached, we start removing plates from the top, computing as we go. This is called the call stack in action. Okay, so up next we will talk about Fibonacci sequence. Fibonacci sequence. Hashtag Fibonacci sequence. Let's look at one more recursive example, which is the Fibonacci sequence. Each number, so what is the Fibonacci sequence? Which is each number is the sum of the two before it. So how it is like? Each number is the sum of the two before it. So each number is the sum of two before. So first it will start at 0, then 1, then 1, then 2, and then 2 plus 1 is 3. Okay, so 3 plus 2 is 5. Okay, after that 5 plus 3 is 8. After that 8 plus 5 13, and then 21, then 34. This 34 comes from these, adding these two. So what will be the mathematical expression? So mathematically we write like fib 0 is equals to 0. Okay, and fib like 1 would be 1. Okay, so uh, fib 0 will be 0, Fibonacci 1 will be 1, and fib n will be fib Fibonacci n minus 1 plus whatever the fib fib n n minus 2. So what is the Fibonacci n? This is the formula. Okay, it will added these it will added these to Fibonacci. Okay, whatever the n value is. So let me just write a function for it. We will say def fib fib fib. Let's just say fib, which is short form for Fibonacci, and as takes as argument. Okay, we will say if n becomes 0, then we will say return just quote unquote 0. If we will say n becomes 1, return 1. Okay, else now we will say return fib n minus 1. Okay, plus fib, this is the second number, which is n minus 2. So we know that what is the Fibonacci sequences? Each number, okay, each number is the sum of 2 before it. So these are the 2 before it. Okay, so let me just say, let me just first write print. So now let me just say Fibonacci of 7. So I have to wrap it in the print statement. So now what is the Fibonacci of 7? So you see that it is 13. So the basic Fibonacci function is correct but slow. Let me just right now we calculated what is the Fibonacci of 7. What if I say 70? It will takes a lot of time. You see that it is still running. It will take lots of time. It recalculates the same value over and over and over for Fibonacci 70. This would take billions of operations. This solution is called memoization, like storing previous computed results. So you see that still this is running. I did not get the value because this is too long. Let me just scale it and back it now with 7. It will perfectly fine with 7 because it's a small value, but it is very slow. So let's just create another function. First we will say, let me just write some cache value, which is like cache is a variable we will define. So first let me just write a repeated value, like we will define a variable which is cache. Inside it there is a dictionary. When we say 0, to give it just 0 value. When we say 1, give it just 1 value. Okay, uh, this is like seed the cache with base cases. Okay, so now let me just define a Fibonacci function, in it takes n as an input or as a parameter. After that let me just say if n not in cache, whatever the n value is, if it is not in cache, so update the value which is cache n is equals to Fibonacci. Now we will writing the function whatever that is n minus 1. Okay, plus whatever the Fibonacci is n minus 2. Okay, after that return whatever the cache n is. So let me just write like Fibonacci 7. Okay, and let me just print it for you guys. So you see this quickly gives 7. So let me just run it like for the 70, how fast it will be. Okay, now when we run it, so you see that it gives me quickly value here. So now each value is computed only once and stored. The second time we need it, we just look it up in the dictionary. So this transform an exponential time algorithm into a linear time one. Okay, we will talk about function as objects. So this is the advanced function concepts. Like we have covered all 10 main topics. And now let me quickly show you three more concepts that will make you a better programming Python programmer. Like this one is the function as object. In Python, function are called first class objects. Like this means you can assign a function to a variable, pass it as an argument, or store it in a result, just like any other value. You just create a function which is even. Okay, it takes x as an regular parameter, and it will return whatever the x modulus by 2 if it is 0. My function, this is the variable which I have created right now, which is says is even. Okay, so now I will say, now I assign function here. Here I assign the function to a variable. Okay, now let me just print is even, 4. It will say yes, even is a 4. Let me just say print is even uh, this number. Is this number even? No, it is not. We know that last value is last value is 1. That's why. If last value is odd, a whole number will be odd. Up next, we will talk about function, uh, returning function. A function can also return another function. This is called closure or higher order function. Let me just write a function which is like def make multiplier like a. In it I define def multiply with b. So now I define a function inside a function. Okay, so I will say return whatever the a into b is. Okay, and I'll then return whatever the overall. So here returns the inner function. Okay, let me just create a doubler. So let me just create a doubler. So let me just create a doubler variable. In it I say make multiplier like 2. Okay, so print doubler. So now 3. So when I run it, it will give me 6. Let me just say print doubler quote unquote 10. It will be 20 because 10 multiplied by 2 will be 20. I can also write a tripler function like just say tripler. Okay, so make multiplier which is 3 because for tripler we need 3. Okay, now I can print let's just say tripler with what? Let me just say with 5, which will be 15. Okay, so make multiplier 2 creates and return a function that always multiplies by 2. Make multiplier 3 creates a function that always multiplied by 3. This pattern where an outer function configures an inner function, which is extremely powerful and a foundation of decorators in Python. So now we reach the end of this video, and this is the last topic, which is documentation string. Documentation string, okay, like doc strings. Good programmer always document their function. Python has a built-in way to do this using doc strings. Okay, a string placed at the very start of a function body. Like let me just say def, which is square number. Okay, let me just say x, and here I can write doc string. To start a doc string, we can use the triple quotes. Okay, also we can use the triple single quotes or triple double quotes. Okay, it's up to you. So here I can say return the square of a given number x. Okay, I will say args. What is the arguments? I will say x, which is a number, int, or it can be a float. Okay, what it returns? It returns the value of x square. Okay, this is just a doc string. You see it from here up to here. Okay, inside the triple quote. So now let me just write the function, which is like return quote unquote x into 2. Okay, so let me just show to you docs on the screen. To write, we will say quote unquote square number, then we will write like dot underscore underscore double underscore, and we will set doc underscore. Okay, okay, so you see that whatever we write inside this doc string, this is our doc string, it will print it out here. If we so the doc, so the underscore double underscore doc double underscore attribute gives you access to the function documentation string. This is the same system used by Python built-in help function. Writing docs string is a professional habit. It makes your code self-documenting. So that's it for today, guys, and that brings us to the end of episode 5, Python function. If anything was confusing, watch that section again. Pause the video, try the code yourself. The only way to really learn programming is by writing code with your own hands. Okay. Okay. If you found this video helpful, please hit the like button. It generally helps the channel grow and tells YouTube to show this to the more students like you. And if you are new here, do not forget to subscribe so you never miss an episode. And also drop a comment below. Let me know which topic was your favorite or which part was confusing. So that's it for today, guys. See you in the next one.